Imagine waking up from a deep slumber to find yourself orbiting a distant star, light years away from Earth. This vision captures the essence of cryosleep and suspended animation, technologies that could make such journeys possible. Cryosleep and suspended animation, concepts once relegated to the realms of science fiction, might be the key to humanity's future among the stars. But how close are we to turning these dreams into reality? Cryosleep, sometimes called induced hibernation, involves significantly lowering an astronaut's metabolic rate. This reduction allows them to survive long journeys with minimal resources. In theory, putting crew members in a hibernation-like state could drastically cut down on the food, water, and oxygen needed, making missions to distant planets far more feasible. The concept echoes what we observe in some animals here on Earth, like hibernating bears or Arctic squirrels, which can slow their metabolism to conserve energy through harsh winters. By replicating these natural processes, scientists hope to create a state where astronauts can endure the vast emptiness of space without the constant drain on resources. Suspended animation, on the other hand, involves putting the body in a state of stasis, essentially pausing biological processes to limit aging or cellular damage during long journeys. Unlike cryosleep, which slows down metabolism, suspended animation aims to completely halt biological functions, effectively putting the body on pause until arrival. Current research has explored therapeutic hypothermia, where body temperatures are lowered to slow down metabolic processes, and scientists have made significant progress in small-scale trials. For example, in some medical emergencies, therapeutic hypothermia has been used to give doctors more time to treat patients, providing a glimpse of how such techniques might be used in space. While we aren't quite there yet for human space travelers, recent advancements suggest it's no longer entirely within the realm of fiction. If these techniques can be refined and scaled, we could one day see astronauts embarking on journeys that last decades, with their bodies essentially paused until they reach their destination. The promise of these technologies lies not only in their potential to make interstellar travel feasible, but also in mitigating the psychological burden of long missions. Imagine being able to bypass years of confinement within a spacecraft by simply sleeping through the journey. The mental toll of space travel is a significant concern, as isolation, limited social interaction, and the monotony of day-to-day life in a confined space can lead to severe psychological stress. Cryosleep could alleviate much of this burden, addressing both the physical challenges, like muscle deterioration, and the mental strain of isolation and monotony. By allowing astronauts to sleep through the most monotonous parts of the journey, they could wake up refreshed and ready for their mission. Of course, there are challenges: prolonged muscle atrophy, potential cognitive effects, and the complexity of safely awakening the crew are just a few of the obstacles researchers are grappling with. Muscle and bone deterioration are particularly concerning, as the lack of movement over long periods could leave astronauts too weak to perform their duties upon arrival. Researchers are exploring ways to mitigate these effects, such as electrical muscle stimulation or carefully timed exercise regimens during periods of wakefulness. There is also the issue of ensuring that the cryosleep or suspended animation process is entirely reversible. Waking up after years in a state of stasis is not as simple as waking up from a regular night's sleep. The process must be meticulously controlled to avoid shock to the body, and even small errors could lead to severe health consequences. Scientists are working on ways to ensure that the transition in and out of cryosleep is as smooth and safe as possible, potentially using a combination of medications and gradual rewarming techniques. As we stand at the edge of a new era of space exploration, cryosleep and suspended animation offer tantalizing glimpses into the future. They remind us that to reach for the stars, we may need to redefine not just our technologies, but also our understanding of human biology itself. The question remains, will we one day be able to sleep our way to new worlds, awakening to entirely new horizons? If we can solve the technical and biological challenges, this could open up the possibility of interstellar travel, not just to our nearest planetary neighbours, but to distant star systems that are currently beyond our reach. The future of long-distance space travel may very well depend on whether we can transform these ideas into reliable technologies. Successfully developing Cryosleep could unlock humanity's potential to explore not just our solar system, but also the vast, uncharted territories of deep space, fundamentally changing our place in the universe. For now, the dream of Cryosleep remains just that, a dream, but one that scientists are working tirelessly to bring closer to reality. As research continues, every small step brings us nearer to a future where humanity can traverse the vast distances of space, not bound by the limitations of our biology, but empowered by our ingenuity and determination. The idea of sleeping through a journey of decades or even centuries is no longer purely the stuff of science fiction. It is a potential reality that could one day redefine our place in the cosmos. If you found this exploration of cryosleep and suspended animation fascinating, don't forget to like, share, and subscribe for more insights into the cutting-edge technologies shaping the future of space travel.